Okay, let's look at number 52. All right, number 52, estimating the date that a prehistoric man died. The bones of a prehistoric man found in the desert of New Mexico contain approximately 5% of the original amount of carbon-14. If the half-life of carbon-14 is 5,730 years, approximately how long ago did the man die? So let's use our formula, and don't get caught up in A of t or N of t. It doesn't matter. You'll see I'm using both. They all mean the same thing. Okay, now we know what the half-life is. In this particular problem, we don't have any other information except for 5% of the original amount of carbon. So I know that what they have found, if I use half-life, is going to be half of the original amount. And then the half-life, which is half of the original amount of carbon-14, is going to be 5,730 years. Now let's solve for K, and then we can answer the problem. So we're going to divide both sides by the original amount, and because it's half-life, it equals half, doesn't it? Now, in order to get K down, we're going to take the natural log on the left side, and we're going to take the natural log on the right side. Now, natural log is the same thing as log base E of E. If these two match, then your exponent is your answer. So we have the natural log of 1/2 is equal to, I'm going to put the number in the front, and now to solve for K, we're going to divide both sides by 5,730. Now we have done this several times by now, so we know that what's about to come is not a pleasant decimal. So we have the natural log of 1/2 over, I'm trying to make it so you can see, and I can still see the calculator, 5,730. Okay, so here we go. That E right there indicates scientific notation. That's times 10 to the -4. So we're going to have to move this decimal 4 places to the left. So that's going to give us -0.3 zeros. And then let's do 5 more numbers. 1, 2, 0, 9, 7. And so that's going to be our K. So now we have A of t equals the original amount times e to the -0.000120097 t. All right, now let's think about what the next part of the problem says. We found K. Now we want to know when this man died, so we're looking for T. We know that he contains 5% of the original amount of carbon that he had when he was alive. So A of t is 5% as a decimal of the original amount. So we've got to deal with this awful decimal. Go ahead and once again divide by the original amount, and you're going to have that 5/100ths left over here, and you'll have all of this. But I hope you've noticed as many times as we have found K with the half-life of carbon-14, it's always been the same number. So go ahead and take the natural log on both sides. So we'll have the natural log of 5/100ths is equal to our favorite decimal in the world times t. Now we're going to divide by our favorite decimal in the whole world. Oops, can't see my decimal. My time is going to be, let's break out our favorite calculator, and we're going to have alpha x equals the natural log of 0.05 over -0.000120097. And that is going to give me, ooh, look at this, okay? So 24,764.25 years, okay? My book rounds that up. I don't know why, but we're going to leave it at 24,764 and a fourth. So we'll do because that 0.26 is pretty close to a fourth. So my time is approximately 24,764 years. Okay? And that is number 52.